Good morning, everybody. Welcome to the video tutorials. If you're writing YA exam or any external exam, you won't regret following my channel because you are going to gain a lot. Also, if you know anyone that is writing any of this exam, you can recommend my channel to that person. Okay, now we'll move into the lecture for today. The last time we talked about electrolysis of aqueous sodium sulfate, where we saw that the factor of position of ions in electrochemical series influence the electrolytic process, and we are able to get hydrogen gas at the cathode, and we got oxygen gas at the anode. So now, but today we are going to look into electrolysis of dilute sodium chloride and concentrated sodium chloride. We are going to compare the two. Let's see how concentration can influence what will be discharged at different electrodes. But before then, I would like you to write on the electrolysis of hydrogen sulfate, that is sulfuric acid, and electrolysis of copper nitrate. So you are going to write how the cathodic equation is going to be and how the anodic equation is going to be, and this will guide you. So in this electrolysis, at the end of the electrolysis, the cathode will have hydrogen gas, the anode will have oxygen gas, and at the end of the electrolysis of this, the cathode will have copper and the anode will have oxygen gas. So I believe if you understood this video, you can follow all this process and you write it based on the compound you have. Now moving into what we have, in this lecture we are going to compare the electrolysis of concentrated sodium chloride and dilute sodium chloride. Let's see how concentration can influence the electrolytic process. Remember that we mentioned three factors that influence aqueous electrolysis, and we say that these factors comes in when we are dealing with preferential discharge of ions. So have this which we have treated, and we are now moving to this. Now when we talk about concentration, this is saying that in an electrolyte, the more concentrated ion will be discharged in preference to the less concentrated. In this case, a more concentrated ion will be discharged in preference to a less concentrated what? Ion or one. Are you getting it? And secondly, this factor of concentration is only effective when the competing ions have a close gap between them. WAEC and JAM usually test students on this factor using halogenated ionic compounds. So whenever you dissolve a halogenated ionic compound, something like sodium chloride, magnesium bromide, calcium iodide, and so on and so forth, halogen simply means it contains chlorine, bromine, iodine. And these halogenated compounds, fluorine is exempted, it's not part of it. So once you are treating the electrolysis of halogenated ionic compounds in terms of aqueous electrolysis, the halogenated compounds we are talking about are ones that contain either chlorine or bromine or iodine. So once competing ions have a close gap, concentration can influence the electrolytic process. The one that is more concentrated will be the one that is discharged, while the one that is less concentrated will remain in what? Solution, disregarding their position. So once you are talking about factor of concentration of ions and there is a close gap between the competing ions, concentration of ions is going to override position of ions. Now moving further, we are going to look into this. So on the left is concentrated sodium chloride, on the right is dilute sodium chloride. The ionization are the same, but you need to know that on the left, concentrated sodium chloride simply means we have more of sodium ion and chloride ion, while dilute sodium chloride means I'll have more of hydrogen ion and what? Hydroxide ion. So on this side, more of the salt, on this side, more of the water. These are the competing ions, they are the same. You need to write all this so it can be a guide to you. Okay, now electrolysis of concentrated sodium chloride is also known as electrolysis of brine. They can ask you what are the products at the anode and cathode during the electrolysis of brine. It is the same thing as electrolysis of concentrated sodium chloride. Brine is saturated solution of sodium chloride or concentrated sodium chloride. Now we move further. So this part is for the concentrated sodium chloride, while this part is for the dilute sodium chloride. Cathodic half equation. Cathodic half equation, we are expressing between sodium ion and hydrogen ion, which one will migrate to the cathode. Okay, now when you compare the electrochemical series, we know that in this solution, sodium ion is more concentrated than what? Hydrogen ion. But the next thing is, do they have a closed gap? The answer is no. Sodium ion is here, hydrogen ion is here. Since they don't have any closed gap, concentration will not come in. They have a closed gap if there are 2 ions between them, or maybe 3 ions between them. But in this case, there is more than 3 ions between them, so they don't have a closed gap. The only thing that can hold in this case is position of ions in the electrochemical series. So concentration only comes in when there is a closed gap. So since they don't have a closed gap, position will influence this electrolytic process both here and here. So sodium ion is strong, hydrogen ion is weak. Hydrogen ion will be discharged. And we have written the equation for discharge of hydrogen ion severally. So hydrogen ion migrates at the cathode it undergoes reduction. What is reduction? Gain of electron. When it gains electron, it forms hydrogen gas, and this is the balancing of the equation. The same thing applies to dilute sodium chloride. Since the gap between the competing ions are wide, concentration will not influence it. So both this and this hydrogen gas will be produced at the cathode. Now move to the anode. At the anode, chloride ion is competing with hydroxide ion. Now, since chloride ion is more concentrated, because it is concentrated sodium chloride, since chloride ion is more concentrated by a factor of concentration, which is going to override position. Since chloride ion is more concentrated by a factor of concentration, which overrides what? Position, chloride ion will be discharged in preference to what? Hydroxide ion. Even though hydroxide ion is weaker, concentration will override position. So chloride ion will be discharged. Chloride ion is going to gain the number of electrons proportional to its valency. So it will now be discharged as chlorine gas. So hence for concentrated sodium chloride, chlorine gas is discharged at the anode, while hydrogen gas is discharged at the cathode. As we move to the dilute aspect, we have said that hydrogen gas will be discharged. As we move to the dilute aspect, since hydroxide ions are more concentrated in the solution, are you getting it? Hydroxide ion will be discharged, following both position and concentration. Hydroxide ion, this solution is dilute, that means it contains more of water. If it contains more of water, that means it contains more of hydroxide ion than chloride ion. This is meant to be chloride ion than chloride ion. Okay, so hydroxide ion will be discharged, and I've talked about how to write an equation for discharge of hydroxide ion. It leads to discharge of what? Oxygen gas. You can look up the previous video I posted on how to write the oxidation equation for oxidation of hydroxide ion at the anode. So we can say that for dilute sodium chloride, oxygen gas is discharged at the anode, while hydrogen gas is discharged at the cathode. Sometimes they can ask you what is the pH of the electrolyte remaining in the electrolytic cell after the electrolysis. For concentrated sodium chloride, the pH of the electrolyte will be dependent on what is remaining. You know that hydrogen has moved out, chloride ion has moved out. We now have hydroxide ion and sodium ion. Two of them will join together to form sodium hydroxide. Sodium hydroxide. I know that sodium hydroxide is an alkali. So pH or whatever is remaining in the electrolytic cell is going to be greater than 7. It's going to be greater than 7. As we come here, hydrogen has moved out, hydroxide has moved out. What is remaining is chlorine and sodium. Two of them join to form sodium chloride. So sodium chloride is a salt made of a strong base and a strong acid. It will have a pH equal to 7. Okay, so this will be, before I conclude this video, there are some questions they can ask you. They can ask you what are the products of electrolysis of brine. We have 3 products: hydrogen gas, chlorine gas, and lastly sodium hydroxide. Don't forget this. These are the 3 products derived during the electrolysis of brine. So I believe so far you have learned a lot with regards to comparing the electrolysis of concentrated sodium chloride and dilute sodium chloride. So with that, this will be all for now until I post a new video. Have a wonderful day.